Hello, ladies and gentlemen. Today we're going to be taking a look at evaluating trig functions, but we're going to use or we're going to evaluate them using the unit circle. So for this, you're going to need a calculator, something to write with, your notes to write a few examples in. Yep, we're going to put a couple examples in there, and we need that unit circle chart that you got in class. Okay, so that unit circle chart, we're going to take some notes on there as well. So let's try to remember a little bit about converting first. So if we're going to convert the following into radians, you have this circle and all of them are listed in degrees. And we've learned that there are different ways to talk about angles. You can measure angles in degrees, but you can also measure them in something called radians. And we've developed that idea of what a radian represents. So how do we convert again? Well, let's take one of these angles here, maybe 30 degrees, and let's convert them into radians. So the formula is degrees over 360 equals the number of radians over 2 pi. So if we place the 30 degrees in where the degrees goes, okay, and we have degrees over 360 equals x, because that's the number of radians we're trying to find, we don't know them, over 2 pi. And now we'll go ahead and cross multiply to solve this. 30 times 2 is 60, so we have 60 pi. And then 360 times x is 360x. And if we divide by 360 to get the x alone, this should all be review for you. X equals, now we'll reduce that fraction, 60 divided by 360, reduce the fraction, it's 1/6, so 1 pi over 6. Okay, so 1 pi over 6 is what we would get for that 30 degrees. If we continue to do this all the way around this circle, we would have all kinds of radian measurements listed next to their corresponding degrees. And this is what it would look like. So please write all of these in next to the number of degrees. Go ahead and pause now so you can complete that all out. Complete that chart and make sure that you have the number of radians next to those degrees. Okay, now when we talk about a unit circle, here's what you should know. A unit circle is a circle that has a center at 0, 0. So we're going to pretend that this circle is on a graph. Okay, but we're going to put that center right here at 0, 0 for ease. And it's going to have a radius of 1 unit, hence the name unit circle, okay? So that means that I have an x and y axes in here if it's at 0, 0. And that means that I can write some coordinates, some x's and y's, coordinate points, for some special angles on my diagram here. So if I'm at 0, 0 and my radius is 1, I'm going to go out 1 unit over here to get to this 360 degrees or the 2 pi. The coordinates for that location would be over 1 up 0, so 1, 0. And if I did that for the 90 degrees as well, here all the way up 1 unit, that means that I would be having a coordinate or an ordered pair of 0, 1 at that location. Then let's go 180 degrees. I do -1, 0 because I'd go to the left one. And then 270 would also have a special coordinate pair or order pair here. We would say that that is 0, -1. So these points also needed to be added to your picture. These are points that we're going to use when we use the unit circle. So when are we going to use this unit circle? You're about to find out. So let's develop this idea that you're going to write on your chart. You're going to fill in a couple things here, those 3 ratios on the side on your chart. But first, let's develop where they come from. So remember that circle's at 0, 0. You don't need to write this part down, but just watch. This is 0, 0. We have a radius of 1, and let's pretend there's a random point xy out here. Okay, xy. And remember, we've been talking about drawing reference triangles because what we're going to need to do is set up our sine, cosine, and tangent ratio here for my reference triangle. So if I draw my reference triangle, if I sketch this line straight down to the x-axis here, I can't necessarily put any numbers on it because I don't actually have any numbers in my xy point here, but I can describe the sides. For example, this distance would be x. That's how far over my point was. And then the y unit would be going up because that's how far up my point was. And then this hypotenuse over here happens to be the radius of the unit circle. So we'll put an r on that. And now if we were going to stand at theta, which would be the angle in my reference triangle, my reference angle there he is, we would now say Let's set up the sign. How do we set up the sign? Well, it's opposite over hypotenuse. So we would say y over r. And then cosine of theta. If I was standing at theta, the adjacent would be x, the hypotenuse would be r. And the tangent of theta is opposite over adjacent. So opposite my theta, across again, y, adjacent would be x, so y over x. These three ratios need to be written on your chart because they're important. Whenever we use this unit circle, we're going to use it at special occasions here in a minute. We're going to need to refer to these three ratios. So it's best to use the unit circle when we have a quadrantal angle, an angle whose terminal side makes it impossible to draw a reference triangle. So what does this look like? So that basically means, let's think about, what if we had the sine of 270? Don't write this part down, okay? But if we had to draw a 270-degree angle, this would be the initial side. We would go 90, 180, 270 would be right here. So I draw my terminal side, and now remember, when we draw that triangle, that reference triangle, put a dot on the terminal side, and I try to sketch a line straight to the x-axis, perpendicular. Well, you can't make a triangle like that, because if I go perpendicular to the x-axis, you can't draw a triangle that way. So that makes it impossible to draw a reference triangle, and that's when our unit circle becomes really handy, okay? That's when we're going to use this. So let's take a further look at that example. This one you need to get in your notes. There's your unit circle, so have it to the side, okay? And those are those three ratios that we wrote on your chart. So now we need to find the unit circle, okay? We need to use that unit circle to find the 6 trig functions for 270 degrees. Okay, so our 6 trig functions include sine of theta, cosine of theta, tangent of theta, and remember then there's cosecant theta, secant theta, and cotangent of theta, okay? So all of these we need to fill out, and in fact, our thetas here, our theta is our number of degrees, so theta actually is 270 here, so I think I'm going to go back in and change all those, and we'd say 270, 270, 270, 270, 270, and 270, okay? So let's change all those to 270. So that whole idea with 270 was a problem because we can't draw a reference triangle. You saw that. So then what do? Well, remember those coordinates that you wrote right there? That's handy for us. That coordinate has an x and a y. The x value and the y value. Now look at those ratios. The sine is y over r. Do we have a y value we can plug in? Yes, the y value in my point is -1. Do we have a radius? Well, on the unit circle, the radius is always a 1. So yeah, so we'll put a 1 right there. And then we go ahead and reduce that, and the sine of 270 degrees then works out to be -1 if we reduce. So we're using that coordinate and those three ratios to just set up the fraction. Well, what if we do cosine? Cosine is the x over the radius. So the x value of my point, notice down here, x, is 0. So we'll put 0 over, what's the radius? Radius of the unit circle is always 1. 0 divided by 1 is 0. And now let's do tangent of 270. Tangent is y over x. So y is -1. The x value of that point was 0. Remember, we're referring to this point right here. 1 divided by 0. Uh-oh, that's undefined. You can't have a 0 on the bottom. Okay, can't have a 0 in the denominator. Now let's do cosecant, secant, and cotangent. Now if you remember, those are just the reciprocals, okay, of those guys up there. So remember those reciprocals, that's what those are. They have relationships. So the cosecant would be the reciprocal of the sine, so I'd have 1 over -1, which is still -1. The secant is the reciprocal of the cosine, so let's go back to our cosine fraction, flip that guy over, 1 over 0, uh-oh, that's now undefined. Okay, and now cotangent is the reciprocal of tangent. So instead of negative 1 over 0, it's going to become 0 over negative 1. 0 does divide by negative 1, and that's just still 0, but that's how that one would work out. Okay, so we're just using those coordinates to help us answer those ratio questions, okay? When we can't draw a triangle, when it's one of those triangles that are impossible to draw, when it lands on an x or a y axis like that, we have to use the unit circle. So let's do another one. Let's do the unit circle to evaluate all 6 trig functions for pi over 2. Pi over 2 is in radians. Notice where that's at. Okay, that's another one of those that lands right on the y-axis, so we can't draw a reference triangle for that. Because it lands on the axes, we can't draw that. Well, what coordinates are there? The coordinates that are right there happen to be, do you remember? Yep, hopefully it's written on your circle. The coordinates right there are 0, 1. Okay, and those are my 3 ratios. Now let's go ahead and set them up. Sine. We have sine of pi over 2 because that's the theta. Cosine of pi over 2. Tangent of pi over 2. Cosecant pi over 2. Secant pi over 2. And then the cotangent of pi over 2. Okay, so now let's set up those fractions. So sine is y over r. Look at your point. Look at your coordinates up there. The y value is a 1. The radius is always going to be a 1 because it's a unit circle. So 1 over 1 makes 1. Now let's do cosine. Cosine is the x value over the r. So the x value is 0. The radius is 1. 0 divided by 1 is 0. Tangent of pi over 2. So tangent y over x. So y is 1, x is 0. Again, this is another one of those undefined. Okay. Let's go cosecant. Remember the reciprocal relationship. Reciprocal of the sine. So if I flip it over, it's still 1 over 1. Makes 1. Secant, reciprocal of the cosine. So now it's 1 over 0, which now is undefined. And now cotangent, reciprocal of the tangent, 0 over 1, which you can simplify to make 0. So the idea that we're working on, ladies and gentlemen, is how does this unit circle help us when it's impossible to draw those reference triangles, okay? When those terminal sides land on an x or y axis, we need to use our unit circle. I want to thank you for taking good notes, and I'll see you later.